Welcome to Data Science with EJD. In this video, our focus turns to logistic regression. Logistic regression, which is a very important algorithm as far as classification under supervised learning is concerned. Our objective here is to model binary classification problems using logistic regression. We apply sigmoid stroke log odds transformations and implement using the Titanic survival dataset. I mean, the Titanic dataset is a very popular one, starting from when I taught data analysis with Python, right? Now, when you hear logistic regression, then it goes generally with the idea of binary classification. And when you say something is binary, it's either yes or no, black or white, off or on, top or down, just two-way classification, basically. So you want to model binary classification problem using logistic regression. So the first thing is let's look at the theoretical foundations of logistic regression. So, first of all, what is logistic regression, right? Logistic regression is a supervised machine learning algorithm used for binary classification tasks where the outcome variable y can take only two possible values. So, y is a subset, is y belongs to a set of either 0 or 1, black or white, male or female, top or down, just like I said before. Unlike linear regression, which predicts continuous values, logistic regression estimates the probability that y is equal to 1 given an input vector x, right? So as you're getting a number for linear regression, you are getting a probability of one of two possibilities from a logistic regression. So the mathematical formulation, step one, you have linear combination of input features. So you have Z equals W transpose X plus B. This we are talking about matrices here, by the way. So X, that's why you need to understand the matrices and all that, probability, statistics, and all of this. That's why it's very important that you should have gone through all those basics before coming this far. So X, you have the feature vector, then you have W, the weight vector, and B is the bias term. Right? I mean, this looks like a regular equation, but I mean now in matrix form. Now we have step two, apply the sigmoid function. Now this sigmoid function is a function that saturates, like maybe a function that rises and then saturates at a point. It looks like S in shape, like if I can make a motion with this, something like this. Okay, well, I mean, why do I even have to do this? I can actually use Desmos, right? So you can really get the idea of a sigmoid function. So let me go Desmos, yeah. And I just click on this to give us the idea of a sigmoid function, 1 over 1 plus e raised power minus x, that is. So I need graphing, right? So we have 1 divided by 1 plus e raised to power minus x, right? Do I need this bracket though? Maybe I don't need this. Yes, this is what this looks like. So you can see this is what a sigmoid function looks like. So you see it rises up from here and then it gets to a point and it just saturates. It doesn't get past this one, right? So whatever is at the top, it doesn't get past that thing. So for instance, if this was to be 2, it rises to 2 like that, and it doesn't get past that 2. That's the idea of a sigmoid function, saturation. And many things in nature get to saturate like this, like the law, okay, maybe diminishing return is not really captured in like maybe a chemical reaction, it gets to a point and it just saturates. You've had it, no matter what you add going forward, you just have it at that point, right? So that's the idea of a sigmoid function. So here, the sigmoid function actually transforms the raw score. The raw score is Z now, which lies between minus infinity and infinity, into a probability P, which belongs to either 0 or 1. So you can see from here that here it's either the thing is at 0 here or it's at 1 here. So that's the idea of a sigmoid function. All right. So the predicted probability is y cap, which is sigma of Z. So you just plug in your Z here, and whatever you, if you, even if you put 1 million here, this value is either is between 0 and 1. It's not below 0 and not above 1. So we talk about log odds interpretation of that whole thing. So the log odds interpretation, the logistic model assumes that the log of p over 1 minus p is equal to that linear combination of input features that we did the other time, right? So the features are x, like we know, and the weight Just like that's like the slope in a line, and then b is like the intercept. So this means the log odds or logit of the positive class is modeled as a linear function of the input features. That's what that means. Then we have a decision rule to convert predicted probabilities into class labels, right? Y cap is 1 if sigma of z is greater than or equal to tau, and it is 0 if sigma of z is less than or equal to tau. So you have that 0 and 1 thing. So where tau is the classification threshold, typically set to 0.5, right? So that's like in between. And then we have the idea of a loss function, which can be based on binary cross entropy. We've talked about entropy, I think, in a video before, and I think it was in what's that, decision trees or something like that. I'm not too sure. One of those algorithms, right? So to train the model, we minimize the binary cross entropy loss because here we are doing something logistical. So we have L of W comma B is minus 1 over N. You have that formula where Y cap I is equal to sigma of ZI. So, and Y is the true label for the ith observation. All right. So you have that. Then let's do a practical example like we always do. So let's talk about the Titanic survival classification task. So here we'll predict if a passenger survived using logistic regression based on several features. Based on several features. So of course we need to import the necessary libraries. We need pandas for data analysis. We need NumPy for numerical stuff. We need Seaborn for visualization. We need scikit-learn, the model selection, train test split. We have 2 used to this already. Then we need sklearn. Here we need the model we are using is learn.linear model. We are using logistic regression. Then we have sklearn, the metrics, accuracy score, confusion matrix, and all these other things. Classification reports, ROC-AUC score, ROC curve, and all that. Then we also need matplotlib to visualize some things. Okay. So don't forget to run this. We run this and that's working already. Okay, now it's done. So we go and load and explore the Titanic dataset. This is not our first time of seeing it. I'm just loading it again for a kind of refresher. So you have these columns, right? Of course, you can do all the info describe. We've done that a couple of times to see the number of rows and columns. So the columns are so we have 891 rows and 15 columns, right? So survived, class, P class, sex, age, number of siblings, patch, and so on and so forth. We have all of this. We've seen this a couple of times, but then to make us really understand the columns, I think this is the first time I'm bringing this out this clearly. The columns we have there. So the Titanic dataset column descriptions survived. It's either integer 0 or 1. Survivor status is 0 if it is no, 1 if it is yes. So if somebody survives, that's 0. If somebody did not survive, if somebody did not survive, that's 0. If somebody survived, that's 1 for yes. P class is an integer variable, which talks about passenger class. 1 is first class, 2 is second class, 3 is third class. That talks about socioeconomic status. It's more like flying in a plane and talking about who is in first class, business class, and all of that, or economy, right? Then sex is categorical. So that talks about the gender, whether male or female. Age is float, which is age of passengers in years. That's like maybe you're 30 years old, 29.5, and things like that. Then SIBSP is integer. Talks about number of siblings or spouses aboard, right? So, like, if you're a man and you have your brothers and sisters with their own spouses. That's what this is about. Then you have the patch, which is number of parents or children aboard. So if you have so parents and their children, we also have this, right? Then you have the fare, which is floats. That's ticket fare paid in British pound, like maybe 4.5 pounds or something like that, whatever that is. Then you have the embarked category. That's port of embarkation. Where did they get on the Titanic? Was it in Sherbrooke, Queenstown, or Southampton? And you have the class, which is also category equivalent of P class, but as string now. So instead of first, second, third, you now have first, second, third in words now as string. Who category, that's description of person. Is it man, woman, or child? Adult male, that's Boolean. Whether passenger is an adult male. Then deck category, deck level, where the cabin was located. Is it C or D, etc. You have embark town, that's full name of embarkation ports. That's whether it is Cherbourg, Queenstown, Southampton. That I feel that's a repetition of what we already had there. Then alive is category. That's text version of survived, yes or no. So it's more like the 0 and 1 we had here. So we have some repetitions in this. Then alone, true if passengers are traveling there. So if you are on board and your family member, your wife, your anybody connected to you is not on board, that's alone, right? So some fields contain missing values, especially age and deck, right? So the basic exploratory data analysis we can do here is to check missing values and summary statistics, which all of that we learned under data analysis with Python. So now that we have all of that, so let's do some processing. For instance, we want to select relevant features. There are so many columns there that may not be useful for what we want to do. So, and here we are selecting data processing. We're selecting relevant features. So the passenger class, the sex, the age, whether they have their siblings and their spouses aboard, or their parents and children are there, or the fare they paid. We are considering those as the features that may decide whether somebody survives or not, right? Because if you're flying first class in a plane, or you are on a ship first class, so you get special protection, special privileges and things like that. So that can determine if there's a shipwreck or a plane crash, where you're flying can determine whether you survive or not. That's the idea right here. Okay. So these are our features now, and then we are creating a data frame called Titanic, where we add the features together plus survived. Then we are dropping all the so these features now plus the survived class, which is our target with these features. Then we are dropping every not available value, every value that is not available. We are dropping them off, so we don't have to worry about missing values. So if I run this now, so you see all this left, so nothing is missing anymore. So we have just what we need: the passenger class, the sex, the age, whether they have siblings and their spouses, parents and children, their fare, and whether they survived or not. Those are the only things we have. So all the missing values are gone, right? So it's more like our pre-processing that we are doing here. So step two, you can now convert categorical features. For instance, sex is a categorical feature. So far, it's male and female here, right? So for machine learning like this, it may be useful to convert them into categorical to convert them into to encode them right into labels. Instead of having male and female, male can be 0, female is 1. So see here we have male and female, but by the time we do this now, all right, by the time we run this, you now see the male and female is now, so male is 0, female is 1, like that. So that kind of encoding is useful, for machine learning. So you see, before we did the cleaning here, right? Up here we had 891 rows, 15 columns. But by the time we selected the features and the survival column, we now have 714 rows, 7 columns. So anywhere there was missing value is gone. All right. And here we still have 714 rows, 7 columns. Now we want to define the features and targets. Of course, we already made our features clear here. All this 1, 2, 3, 4, 5, 6, I think. Yeah, 6 columns like that. So here you say X, that this is standard. X is the data from all the features. Y is the data from of the survived, which is your target. So we run this, that is on already. Then this is just to visualize it, right? So we have these are the features now, and then Y talks about the target, which is about survival. So the name is survived, and 714 of them, and they are all integers. They are categorical in nature, by the way. Then we can now do our 10 test split. So this is standard by now, you should know. So X train, X test, X train, comma, X test, comma, Y train, comma, Y test equals train test split, which is a function in sklearn, I think, model or something like that. And then you have XY test size. We're using 20% as test and 80% as train. Then the random is to make sure that nothing, the result never change. So I run this and that's done. Then we go to now train the logistic regression model. So we call the model, logistic regression. So the maximum iteration we want is 200. We can make it more, we can reduce, and then we fit in the second line. We do that and that's done. Okay. So that shows us it's done. So you can see the logistic documentation by clicking on this now. So all these things like this. So it shows you if you want to learn more about it, you can have this. Okay. So now that we have trained the model, the next thing we want to do is to evaluate it to see how it to get some value. So we want to predict and evaluate, right? So Y-pred can now be modeled or predict X test. Then Y probability, that's modeled or predict probability X test one, like this. So since it's based on probability, okay, that's done. And of course, if you want to visualize any of this, you're free. Say I can escape and create two down here. So if you want to see widespread, you're free. You can just put this here and run, and it shows you all of these things. So it tells you whether these people survive or not. That's what this prediction is all about. Then if you want the probabilities also, you can do that. So put this here, run, and then it shows you all the probabilities of those survive. So this person does not survive, for instance, and the chance is 0.16. That's the chance of survival, right? So, and this person, this third person survives, and you see the chance is so high up here. So this last people survive, so the probabilities of survival will be very high. So 0.96 and 0.88. So we can also visualize all that, right? Okay, so step two now, we want to print some performance metrics, right? So we want to see the accuracy, the confusion matrix, classification reports, ROC, AUC. Now, in some 2 or 3 videos from now, I'll be talking about just these metrics. They are, so we're digging deep into these metrics, how they are calculated and things like that. So here you see the metrics, the accuracy, the overall accuracy 0.748 or 0.75 to 2 decimal places, right? So you see the confusion matrix 71, 16, 20, 36. Now you'll understand all that when I talk about metrics. Then classification reports. So I mean the model does fairly good. We have some 0.78, blah blah blah. So see, for the precision for survive, for those who, I think our focus should be on survival, right? So there's a high chance following precisions, right? We have a, I mean, generally we have higher chance of not surviving, right? Compared to surviving. So here it tells you that 87 survive and 87 do not survive and 56 survive. Basically, that's what this is about. And then we have the whole ROC score. And then we can have a plot for that too. So this is a plot for the ROC curve like that. So you have the false positive rate on the x-axis. False positive means that so if the model predicts that um they are going to survive, and it is actually not true that they are going to survive. Something like that. That's that what false positive is. True positive means the model predict they are going to survive, but and they actually survive. That's true positive. So the ROC curve takes care of the relationship between these two. You get a bit better understanding of this by the time I talk about classification metrics. So coefficient analysis. So talking about feature importance now, we want to see the most important features, right? So for the coefficients, you have PD dot frame. It's like you want to see so it's a regression, right? It's a classification, right? But it is still a regression all the same. So in regression, we always talk about features, I mean coefficients, which actually tells you how important each feature is, right? So we have coefficients, PD dot data frame. So feature X dot columns, coefficient, model coefficient, 0, then sort values by coefficient in ascending, in descending order because ascending is false, right? So I think I just like ascending order. Let's do it in ascending order. So the best from start from the top. So we print this. So you see, um, oh, ascending true, meaning it's in ascending order. Okay, let's do it. Let's do ascending false actually. That's what I actually wanted is, yeah. So you see, in this case now, if sex is top feature to determine who survives or who does not. So mostly um when things happen, right, women are given preference and children, right? So sex is a very high, has high coefficient, meaning that if you are a woman, most likely you are going to survive on the Titanic, something like that. Then fear also determines, of course, fear correlates with whether you are in first class or second class or third class. So those in first class, they have some chance of surviving too, like that. Then you now see that age, having parents or children on board, having siblings and their spouses, and all that don't they contribute negatively to whether you survive or not. So the ones that have positive contribution are sex and fair. All this age patch, SIDSP, P class have negative effects. So if you have a large family, if you are alone, right, it's easy to just escape. But if you have kids, you have a spouse, you want to watch out for your spouse and things like that. So that's something. So age is also negative in that regard, right? Meaning that you know, I don't know what exactly to say that, but age doesn't contribute negatively. So positive coefficient increases chance of survival. So sex and fair increases chance of survival, while age, patch, SIBSP, and P class they have negative coefficient, so they decrease chance of survival, right? So in summary, let's look at some summaries and takeaways. So some key points now. The concept is that logistic regression models probability using sigmoid and log odds, like we've seen. The math is that it's logit in nature. So we have log of p over 1 minus p is equal to w transpose x plus b. Then the outputs give us probabilities for binary classes, and the loss is binary cross entropy, which is a log loss. The example, we have Titanic survivor classification, which we just done. Evaluation is based on accuracy confusion matrix, ROC-AUC. Interpretation is based on coefficients, which indicate feature impact on survival. Then we talk about possible extensions now. How can we extend this model? So impute missing values. Instead of eliminating missing values, we could impute missing values by just putting median age for everybody available, or average age, or any how we want to do it. Then you can do feature engineering to, like, for you can get a new column called family size by adding up the siblings and their spouses, and whether you have the parents and children are on board. Then we can also regularize, right? We can penalize the system, like we can use L1 penalty from lasso. I think we're going to talk about lasso along the line, lasso regression, ridge regression, and all of that. Then you can also do pipeline and cross validation with scikit length. So these are possibilities you can do. You can use other data sets to also check to see how the model performs, right? So this is how this has been. Thank you for listening. Let me know how helpful this has been for you, and if there's something you'd like me to try out, feel very free to let me know. If you have subscribed, thank you. If you have not subscribed, please go ahead and subscribe, and be sure to hit the notification bell so you can always get alerted each time a new video is released. And if you want some special privileges, you can become a member of this channel, right? And like and share this video also, so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.